Good afternoon, everyone, and welcome to our webinar, Energy Rules, Closing the Circle Between Design and Operations. And my name is Karen Butler, and we have a very exciting webinar presentation for you today. And let's get right into it. So our speakers today is going to be myself, and I manage the Commercial Building Design Program for the U.S. EPA Energy Star Program. We have Megan Jancy. She's a principal at MTFA Architecture. We have Aaron Luau, Corporate Energy Utility Engineer for the Kroger Company. And joining him from Kroger is Mike Delicave. I hope I'm pronouncing your name correctly, Michael. And he's the Manager of Mechanical Services for the Kroger Group. And then Josh Horn. And lastly but not least, we have the Principal and Director of Retail Studio and KLH Engineers. And he is joining us today. Typically, we've had these sessions. This is our second in a series. And this time, as opposed to having the architect, we have the engineering firm representing and talking about how they've worked with Energy Star to close the cycle between design and operation. And we have the learning objectives, and I'm not going to go through them all because before each attendee or each panelist present, they're going to talk a bit about the learning objectives that they're covering. And as you can see here, we're going to do, and I'll just briefly mention, we're going to talk about minimizing risk. We're going to talk about energy disclosure, which will be Megan, and how those policies could possibly affect the design process. We're going to talk about metrics and targets. And then lastly, we're going to examine some real-life cases where the architect and engineer have worked together from design through operations to achieve their performance goals. And as we present, if you have questions, please send them along to our host, who's Zach Sheelan from the Cadmus Group. And we couldn't do this without him. He's kind of navigating in the background for us. So getting started with the learning objectives in the part that I'm going to discuss. Oftentimes, the architect and the owner start out at the beginning, and then the architect goes off, and then the owner comes back at the end when they hand off the building. And what this presentation is about is how do you engage your architecture and engineering firms through the process of design and having the owner be fully engaged so as decisions are being made about design strategies that affect energy performance, the owner is engaged and can also give feedback to the A&E firm so that they can make cognitive decisions so that the building can actually achieve the intended goal. And that leads us into this slide where we talk about the energy life cycle process. And what is that? It's setting targets early in the process, setting an energy design target. Oftentimes you set target goals for other aspects of design, but in this particular presentation we're focused on energy. And then when you set the energy design target, if you look at the bottom of the slide, it says achieve intended performance goals. And what that means is that at the end of the day, you're designing and building a building for the occupants to take possession of that building. So once it's completed and occupied, you want to make sure that it's going to achieve the intended performance goals. The next one is to select the design strategies, and again, to achieve the intended performance goals, so that the goal, the strategies you're going to use all consummate with meeting this goal at the end of the cycle where the building is going to be operated and the occupants are going to take possession of that building. And then after this building design, then you measure performance. You track, monitor, and measure performance. Calibrate the building, calibrate the systems to make sure that they are synchronized to the occupants' needs for doing the tasks that they're doing in the building. And again, to achieve the intended performance goals. So this whole cycle, it's about connecting things together so that energy is not looked at this isolated process or this isolated thing that's over here that no one understands. We're trying to connect it up so that the process is able to deliver the intended building that you're looking for. So as we go forward, the industry is beginning to head to a more outcome-based compliance. And the architect and engineer now have a significant role in ensuring that energy performance is integrated in the overall building design. So what does this all mean? This was a statement that I took from an article from the American Institute of Architects. And more now, the engineers and the architects are beginning to realize that the decisions they make in design are being translated to the building, and they're being measured, and people are looking more carefully. If you look at the graphic at the bottom of the slide, there's New York City's benchmarking and disclosure activity. And what they're doing now is they're actually showing the energy performance of these buildings. There's not a particular target set yet that they have to meet for each building, but most of these jurisdictions do have broader targets that they're looking to meet in order to reduce their consumption and their greenhouse gas emissions. So with that being said, doing it early in the process is going to get you to that objective a lot better. So getting to those objectives, so why does an energy performance, why is it not integrated into the overall design process? As many of you know, business as usual, the metrics that are set for design are oftentimes different from those that you address in the operation of the building. So therefore, if you're designing to one target and then measuring operations on another target, then there may not always sync up. So one of the things with this process using Energy Star tools and resources is to try to get the same target you're using in design to be the same one you're using in operations so that you can use those to quantify the activities and then link up the two, design and the operations. And there's a lot that goes in between. And our presenters from Kroger are going to tell you about real-life experiences. The second one is not accounting for all the operating energy. Oftentimes, the architect and the engineering firm may be a little bit amiss of what those are. And again, as I started out in the beginning when I talked about minimizing risk, this is where the owner plays a key role and feeding back information, being in the various meetings and helping the design team understand what their operating objectives are. And then lastly is the feedback. Architects and owners getting together and engineers getting together and talking about what happened in the design, how it was translated to the performance, what worked, what didn't work. So that leads us into the first one is setting targets. So I'm going to talk a little bit about some of the targets that are out there, and then I'll focus in on the ones that we're going to talk about in the presentation. So the first one I have is benchmark-based performance targets. And any and everyone can do this, whether these buildings have an Energy Star score or whatever. And basically all that is that you measure performance of a building that you're familiar with or that you're using, and you use that target to guide your design decisions. Albeit, you may not know how efficient it is compared to a peer of its buildings, but nonetheless, you know if you've done significant upgrades in the building, or if not, you know where that target is coming from. The next one is the CBEX data and the EUIs from there, and the CBEX is the Commercial Buildings Energy Consumption Survey from DOE. And what that is, they go out and they take a survey of a population of buildings, and then they synthesize them all together, and they have like buildings together. So they have a survey for K-12 schools, a survey for retail groceries, a survey for hospitals, et cetera, and et cetera. So that's another source. Energy cost budget, which is usually associated with ASHRAE 90.1 and codes, where they're looking at the cost of energy. They use that to set a target, and then you design your reference, you have your reference building, and then you design your building as proposed to be better than that reference. And then I should have switched these two, the next two, site, source, EUI, and total annual energy. I should have switched that with Energy Star metrics, because the Energy Star score and metrics are a combination of site and source, EUI, and total annual energy. And I'll get into that a bit more in the next slide. So the Energy Star score is a 1 to 100 metric that lets you take your benchmark-based performance target, let's say, and pop it into a scale to see how it fares against other buildings that are its peers. So for an example, we have the Kroger company who's going to present with us today. They can take their grocery stores, put it into the portfolio manager, and then get an Energy Star score. And what it does, it compares their buildings to the population of buildings that are in the database. And then from that, it does the regression analysis and analytics to determine what their score is. And so on a 1 to 100 scale, you would get 1 to 100. And what's nice about it, it's a progressive scale. So if you're 1 to 25, your building needs improvement, or your design probably needs improvement. 25 to 50, you're beginning to make some adjustments and getting that building close to typical, 50 to 75. You can continue to do enhancements, 75 to 100. Then you're in the superior performance range and you want to maintain or improve your activity. The other unique part about it is that if you have an EUI, it will tell you where that EUI fits into the context relative to other buildings. And the number from the ENERGY STAR score is a number that all stakeholders can understand and use that as a way to have discussion about performance. So next one, we're going to talk a little bit about the score. And in this presentation, we're going to do an update to our metrics in Portfolio Manager in mid-2018. And as you can see on the graph to the left, some of those scores are going to go up. Some of those scores are going to go down. And this is because as we receive the new data, the 2012 data, the industry has changed. Energy efficiency in some cases have become more pronounced, and in other cases, it has maintained itself. So this is why you see some changes in the scores. But I'm not going to go into great detail about this slide, but what I am going to do is invite you to join us on the webinar on Tuesday, February the 27th at 2 p.m., preparing for ENERGY STAR's Portfolio Manager Metrics Updates. And in that particular webinar, they're going to go into excruciating detail about the scores, score changes, and what's happening with the new metrics. But I do want to focus a bit on the features and the metrics here. So the national source energy factor for electricity is going to decrease from 3.1 to 2.8. The two options for benchmarking data centers, there are going to be two options for benchmarking data centers now, so you have more flexibility there. And then you're going to have an enhanced electric demand tracking, and then there's a water scorecard for multifamily. Unfortunately, only the scorecard is for the multifamily. It's not for the other properties as yet. So do join the webinar on the 27th if you want to understand more about the score change. So Portfolio Manager, you've heard me mention the word a few times. This is the driver of all of the things that I presented before. This is how you get a score. This is how you receive your EUI. This is where we take and we calculate your score using what we call weather normalized information. So when you get your ENERGY STAR score, it's not just a score relative to just other properties, but it's also relative to how well your building uses energy or how well your design intends to use energy, because it's a comparative system. You can also track and calculate your water consumption. We don't have that on the design side yet. That's only for the existing properties. You can track greenhouse gas emissions, and you can also get estimated greenhouse gas emissions when you're doing your design as well. And then, of course, the 1 to 100 score is available for about 17 property types. However, for all other property types, if you're doing it for existing buildings, you can benchmark anything in Portfolio Manager and compare it to yourself or other targets you may want to set. And also on the design side, you can pick out those particular properties and you can receive an EUI, an energy use intensity for it, number for it, but there will not be a score related to it because we don't have enough data on those particular properties to do the normalization. So now going to the next slide, some of the information from Portfolio Manager, you can look at your design targets and your design project and compare your project to your target and to the median building. So here in this slide, you can see that your design project received a 76, your design target was a 75, and then the median is a 50. And then from that, you can see if you are meeting the goals and objectives that you set for your design project. Your design project is the estimated annual energy use that you've entered into the tool, and that's what produced those numbers. And then if you look at the top graphic, you'll see the little up arrow saying that you have achieved your target and you've also have achieved a better performance than what your median is. Whenever the arrows are green and up, that means you've achieved. If they're red and down, that means you haven't quite achieved your goal. So you may want to go back and make adjustments. And we recommend it when you're doing a design that you definitely shoot higher than 75 or higher than your intended goal to give yourself the latitude if there's a operational changes. So the idea is to design the building with the intent to operate it with superior performance. And the last thing that I'll mention on this slide, for those projects that receive 75 or higher, they're eligible for Design to Earn the ENERGY STAR, which is the recognition of a design project that meets the criteria for getting the ENERGY STAR mark on the drawings. And moving next. So this just leads back into another quote that I pulled from the same article to talk about that the profession, if you're looking for looking at a carbon neutral future, it becomes increasingly more important to connect design expectations with actual performance. And this was music to my ears when I saw this, because oftentimes architects throw it over the fence, the engineers throw it over the fence, here, Mr. Owner, Ms. Owner, and go do your thing, and, you know, everyone's happy. But that's not quite the way it's working anymore. So now people are beginning to move into a more collaborative process. So in this particular slide, we're showing where we actually looked at the performance of the building after the design process. And in this one, if you look at the left-hand graph at the top, you can see they put their energy meters, those little lines in there are actually energy data being tracked. You have your natural gas and electricity. And then at the right-hand side, you see the bar graphs. So now you can see how your project, your target, and your median all compare to one another. And again, the graph at the bottom shows you the numeric numbers. So I'm going to zip right along so I can pass off the baton to Megan. But connecting building design to expectations with actual performance, and looping back to the earlier slide, we talked about using the same metric, owner and architect and engineer engagement. And then the other part is educating the occupants about the energy efficient features in the building so that they can actually be a participant in the performance activity. And this is just a highlight of the process using the energy life cycle, using ENERGY STAR and Portfolio Manager. And we also have a little tool called Target Finder where you can set design targets, but you can't track your energy use in it the way you can after the building is built and performing. So just quickly, at design, pre-design, you can use it to set your targets, use it in a facilitated charrette, have the owner and all of the key players involved. Schematic design, you look at your opportunities and your building massing and the big picture items, how the building is sited, how it's, collects daylight and so on. Design development, when you get into more refinement, again, go back, check your targets, make sure that you're on track. And then when you get to construction and bid documents, that's when you can actually apply for the Design to Earn ENERGY STAR recognition. And then from there, you have some downtime for the building as it's going through construction. And again, if there are change orders being made during construction, you should recalibrate the energy, making sure that you're staying on track. And then once it's built and operated, you commission the building, do the M&B, make sure that you're meeting the goals, and then when it reaches 12 months or greater, you can apply for the ENERGY STAR certification for the building. So that's that graph. And then these are just a couple, a bit of a shout out for what's going on in the ENERGY STAR program. We have over 500,000 properties that are being benchmarked. 30,000 of those have received certification. Nearly 800 have received Design to Earn ENERGY STAR for commercial new construction properties. And of those, 42% is the average CO2 and energy reduction, and then the average ENERGY STAR design score is a 90. And most of them, again, shoot higher to make sure that they can achieve the objective in operations. And then architects have been working with us, architects and engineers have been working with the with ENERGY STAR to do Design to Earn ENERGY STAR and help their owners with the first step of achieving performance. And then next we have the owners that are asking for energy efficiency in their buildings because they want to make sure that they meet these goals and objectives. And you can see on here the Kroger Group is one of our big players. They do a lot of benchmarking. They have a lot of stores that have earned Design to Earn. They have a lot of ENERGY STAR buildings, so they're a very good partner in letting us and being able to highlight the objectives. So now I'm going to pass the baton over, or the baton, the little ball, to Megan, and Megan is going to talk about energy benchmarking policies. Megan, on to you.
Great, thanks, Karen. I want to just touch base on the idea of what are the benefits of energy benchmarking and explore how we can begin to implement benchmarking policies at a greater level of collaboration occurring on project teams. Is it possible for us to improve performance and deliver projects that will really enhance the environment? And that's really what we're going to address here to kind of start this when we talk about benchmarking policies. In the article that Karen's been referencing, it's pretty clear that architects are already beginning to deliver buildings that are performing as they're designed, and that's really being driven by what the market demanded of us. Further, energy disclosure laws are going to begin to require architects and design teams to actually provide the performance data back when a building is leased or sold, and that's becoming more widespread throughout the United States. So how is this going to affect what we do during design? This is a statistic that seems to fluctuate but not change too much, in that 40% of the world's energy is being consumed by buildings, and that at the same time we're releasing 21% of the greenhouse gas emissions back out into the atmosphere. But what's really interesting is 54% of the energy that we use in buildings is consumed primarily from HVAC and lighting alone. And so it's really important to understand how those are being measured and what the impacts are those disciplines have on our building. The first key measure is really actually just measuring what we're doing. If we're not measuring something, then we can't manage it. If we don't understand what's happening, if we're not looking at the data, if we're not actually seeing how a building is performing, how are we able to actually measure our building's performance over time? And so there are several tools that Karen started to talk about, from Target Finder and Portfolio Manager tools, that are helping us to do that. And that's really a key benefit for the design teams, is having a central location that can be shared both with our owners and our engineers in order to be able to create these files. So the key benefits of benchmarking, the idea that if you reduce your energy consumption, that this will result in a cumulative energy cost savings over a building's lifetime. This in general would lead to a more comprehensive energy efficiency improvement that can occur in buildings, and that's being measured. So in the end, we often see a greater competition in the marketplace with real estate as well as economic growth, as there's higher demand for higher performing office space or buildings in the marketplace. And this is true for both existing and new buildings. This is a map of the United States showing where benchmarking policies are being implemented. So there's many jurisdictions that are moving in the direction of a true performance-based energy code compliance. So they're requiring 12 consecutive months of a code-compliant performance within 3 years of the delivery of a building. Several of these jurisdictions are opting for a voluntary compliance to start out, and then requiring it or becoming a mandatory compliance over the next few years. And so you can see this is becoming widespread across the United States. It's not isolated to one particular area, but I'm going to address how it's specifically affecting projects here in the Washington, D.C. metropolitan area in a little bit. So here are some examples of what we're seeing in our local policies. We have developers that are agreeing to complete energy portfolio manager reports for a reporting period of 10 years. So they're installing energy monitoring equipment inside their building, and it's tracking the whole building's energy use data. It's reporting it back to the jurisdictions, and also the developer agrees to achieve an Energy Star certification with a score of 75 or higher within 48 months of occupancy of the building. And this is also put into a bond. So there's money, real money on the line for our developers if they don't hit these requirements. And so this is a real implication back to architects and engineers, because they need to be able to achieve what they're promising back to this jurisdiction. And so how does that affect our documents? It's mostly in our MEP systems. It's installing the infrastructure that our buildings need in order to be able to report the information back. So every jurisdiction will have a little bit of a different metric or a little bit of a different requirement, but the idea here is that using a tool like Portfolio Manager, we're able to actually communicate back and forth and get our buildings into a central database. So what does benchmarking look like? The idea is that we're not limiting what our buildings look like. We're not saying you can't do glass. We have plenty of all glass buildings that will still meet ENERGY STAR requirements, but it's understanding the building envelope, building and specifying, detailing a tighter envelope to improve our efficiencies and working through energy modeling. So this is an example of a school project that is able to be designed to meet ENERGY STAR, is currently being tracked in its first year of occupancy to hopefully earn the ENERGY STAR sign in the future. Office buildings, it's happening in, doesn't matter whether it's size or shape, but it can occur in office buildings, and it can also be done in multifamily. So as Karen mentioned, several building types, but benchmarking isn't just limited to what, or trying to constrain what our buildings really need to look like. And so now I'm going to pass this over to Aaron and his team so that they can discuss the mechanical systems and their experiences as an owner.
Well, I'm going to hop back in and introduce Aaron and Jeremy and Josh and Mike. And they have been, like I said, a partner with ENERGY STAR for quite some time. They've done a lot of work, KLH Engineers. And Jeremy, I apologize that I didn't change my graphic to say Architect Engineers. And again, today we have the E presenting instead of the A. So they're going to go over some of the activities and some of the mechanics and some of the specifics that they've used in order to meet ENERGY STAR. So with that, I'm going to pass the baton over to, or the ball to Aaron.
Thank you, Karen. So as Karen said earlier, my name is Aaron Leo. I'm one of the utility engineers here at Kroger, and with me from Kroger are also Mike Delikoff, the manager of mechanical services, and Josh Warren, working in facility engineering, mechanical design. And I'll let Jeremy go ahead and introduce himself.
Certainly. My name is Jeremy Toy, KLH Engineers, principal of Retail Studio and head of our Kroger team. So to begin, we'll discuss the session outcomes for our portion of today's topic. The overarching theme that you'll see sprinkled in throughout the discussion, I want to touch on the metrics for the afternoon. One of our key goals is to combine green decisions with good equipment ROI. As you'll see, results will show that Kroger stores operate at a very high level of efficiency. Any revisions that we make to our best practices evaluate both the energy impact and the ROI of that initiative. We're also going to get pretty deep into touching on the connection between the design team, A&E, and the store owner, Kroger, and the store operators. And then lastly, we'll touch on the lessons learned. Did we save what we actually expected to save?
So behind all of this is a need for verification that, one, the predicted energy usage is performing according to the design expectations, and two, that the actual energy usage is improving as well. So one method that we can use for this is looking at the design to earn the ENERGY STAR score in conjunction with the ENERGY STAR score itself once we have a year worth of data, as Karen referred to earlier. So to better take advantage of these programs, we recently improved our process a little bit, where with the old process, the responsibility landed mostly with the MEP and the architect. So the MEP and the architect created the portfolio manager property. They then communicated with Kroger and one another to complete the remaining documents, the letters of intent, the statement of energy design, intent, etc. And they would submit the application. And finally, after that, they would transfer the property to us so that we could then add our existing utility data into the system and compare the design score to our actual score. But under the new process, the responsibility has kind of shifted more toward us, the owner, where we create the portfolio manager property, and then again work with the MEP and the architect to complete the document, and we submit the application for Design to Earn Energy Star. And basically this eliminates the final step of transferring the property because this allows us the assurance that we're going to be able to track the property along with the design score. So both methods work, but we were getting caught up in the transfer of the property itself, and so we were missing a lot of that communication which required us to get the property under our portfolio manager account. And so in a lot of cases, we weren't able then to compare that design score to our actual score. And so we'll dig into some examples of how we use this later. But first, we're going to take a look at how we and our MEP/architects collaborate to achieve our design and performance goals.
So looking at the connection between the design team and the owner-operator. Kroger and KLH, we have an established marketplace prototype that can be modified based upon region and climate zone. Kroger modifies their fixture plan typically to fit region-specific needs, and KLH uses engineered starting points that are modified based upon region, climate zone, and the fixture plan changes that Kroger makes. Step 1, the prototypes are often amended as Kroger pursues new energy cost savings initiatives. They can do that internal. Dissimilar from some owners, Kroger has their own engineering expertise in-house, and they may deliver some ideas that are completely based to the engineering team to put into their stores. Or they could look to a consultant, ourselves for example. KLH has designed retail environments in all 50 states, and we may suggest certain initiatives based upon what we see in the retail world at large all across the country. Step 2, we look to perform energy and cost analysis of the initiatives that we work with Kroger to establish, specifically via energy modeling and construction cost estimating software. Step 3, the initiative is actually put, designed, and constructed into a store project. Step 4, once constructed, the performance data is gathered. And step 5, the data is evaluated, usually internal to Kroger, although KLH or another consultant can be involved. Now, before I leave this slide, I just want to mention briefly my history with Kroger. I've worked very closely with Kroger for 11 years, and KLH has worked with Kroger for over 2 decades. And this rapport between the owner, the architects, and the engineer breeds continual evolution of this process that you see here. We're almost always in the throes of reinventing some aspect of store design, many of which we'll peek into today. So I mentioned Kroger has an established 123,000 square foot marketplace prototype, and the prototype does get minor modifications to certain departments, for example, based upon what works with the specific site or region. For example, you'll see certain departmental elements in a Fred Meyer that you won't see in a Fry's store. And further, you'll see a few that may be in a Fry's store that you won't see in a Midwest marketplace store. With exception to the minor modifications, varying climate zones, etc., we see that the Kroger store design rarely needs modification to meet energy code. Now, of course, utility requirements, local codes, local ordinance are always exceptions to this rule. Our performance method energy model that we use specifically for all of our marketplace stores, it compares the energy consumption and the savings to the energy code baseline, and then we share that information with Kroger. We have designed a Kroger store in every climate zone in which they operate, so that gives us a bit of an advantage. We specifically use those engineered starting points, what I'll say are energy model templates. We specifically use those for greater internal efficiency, for a better quality assurance, and a greater likelihood that the plans will pass plans examination the first time they're submitted. This is going to help get the construction process off the ground a bit sooner, and it could lead to earlier grand opening dates for Kroger. some of our energy initiatives, obviously we will design, as the professional engineer of record, we will design each store to meet or exceed local energy codes. Now, the tradability of certain aspects of the performance method energy model allow us to key in on certain metrics of those green decisions with good equipment ROI by allowing us to more closely examine things like roof insulation when compared to the prescriptive method, which when looked at singly can be a bit more stringent, I'll say. KLH compares the energy consumption and savings to the energy code baseline, as I said, and we share that information with Kroger. And Kroger goes back 1 year later to verify the actual savings, and we collectively will modify the prototype based upon those findings to best take advantage of the data. Regarding the lessons learned, I'll look at Palmer, Alaska, Fred Meyer store that we had helped design. The envelope and the mechanical systems there were handled very differently, as you can imagine. It had to be increased to meet the demand of the colder climate. KLH, we worked with the architects multiple iterations of our energy model to help hone in on the envelope and the mechanical specs that would meet energy code requirements, keep the space comfortable, but then also remain cost-effective for the owner.
All right, hello everybody, this is Josh Horn. I work in our mechanical design group for Kroger. And what I'm going to be discussing is the relationship between Kroger and KLH and how the new designs that we come up with are implemented into our stores. With our ongoing construction schedule, we always have a slate of projects that are currently being designed, being built. We're always looking for ways to improve upon our prototype and get those implemented into our new designs. This is typically done in one of three ways. Because of our large existing store base, we have the ability to go out to develop, test, and validate new energy initiatives on that existing store base. Once that idea has been vetted, we will look and see how we can implement that into a new construction project and get those rolled out for the new designs. Other times, we'll have an idea, we'll propose that change to KLH, work with them to develop kind of the best practice for that design initiative and get their feedback there. And other times where we are looking at an entirely new initiative that we don't have a whole lot of experience with, we will rely upon KLH and use their experience in other projects, other applications to get some ideas to move forward.
And going back to, again, the history that we have with Kroger, this is Jeremy, KLH. We've also assisted with creating new or updating some of Kroger's standard details. We've helped with specification updates, be it eliminating manufacturers who may not be in business anymore, or updating per energy codes, mechanical, electrical codes, etc. We sometimes help Josh with updates to the HVAC design philosophy or wording there, and then we still maintain Kroger's electrical switchgear template, which we will modify if new innovative equipment is put out to the market or new electrical codes make certain requirements that cause us to modify.
Yeah, and following up on that, when we do roll something new out, it's rarely finished after that initial rollout. Once it's rolled out, we get some run time, we take our lessons learned and roll that back into the design for the next project. So it is an ongoing process. But here we'll look at a couple of the initiatives that we've rolled out over the last couple of years. So on the HVAC side, we have switched to a dedicated outside air system design where we treat and supply all the outside air through a couple of dedicated units for the sales floor. Our buildings are unique, whereas the refrigeration systems inside our stores, the efficiency of those systems is heavily impacted by the moisture content in the air. So there is a desired level of moisture in the air that we design to maintain a specific dew point inside the store. So with this, we work with KLH to figure out the best way how to kind of spread that latent and sensible capacity out through the HVAC units and how best to control the amount of outside air that we're bringing in We do want to stay positive, but we don't want to bring in excessive amounts of outside air that drive up energy costs. So the next item there on the electrical side, electrical and building control side, is the implementation of case controllers. The case controllers work with electronic expansion valves that provide a lot of benefits to the control of our refrigeration systems and cases. What they allow us to do is to control that case to a tighter temperature, which leads to increased energy efficiency. But with that, the introduction of case controllers had a big impact on the electrical design for the store. So working with KLH, they were able to help us put together kind of our best practice and our standards for wiring of these new systems.
At first look, as I say, the case controller strategy did not look very lucrative when plugs played directly into what was our electrical prototype at the time. So as Josh mentioned, we looked at the store more holistically, and using the case controllers to the fullest advantage, we were able to eliminate panel boards, we were able to eliminate contactors for control, a lot of conduit and wiring, and more importantly, a lot of contractors' construction hours and dollars that went into as many circuits as we had previously used, and it really improved the ROI to the point where it made it a no-brainer to use that for our new marketplace stores. Moving further, lighting. This is something that is constantly changing, not only in the built industry, but specifically with Kroger. Kroger undergoing a shift to more or sometimes even all LED lighting. For new marketplace stores, the vast majority of our lighting is LED. For remodel projects, we may have a lot of existing fluorescent lighting in the space where the traditional use of LED might be tracked, and Kroger is going back to retrofit many of those stores by putting in LED in as many places as we can. KLH, we also introduced a new method of lighting control and lighting circuiting that saved Kroger hundreds of thousands of dollars years ago, specifically with regards to LED and track lighting. Again, eliminating, in that case, a few panel boards, a lot of contactors, a lot of conduit and wiring, and it gave us a sharper edge towards compliance with energy code, specifically those codes that require us to, those jurisdictions that require us to use the prescriptive method in lieu of our preferred performance method. Lastly, here on the slide, an initiative that we recently have undergone are a reduction to the number of skylights in a marketplace store, I'll say. Previously, we had covered the entire sales area sprinkled with skylights. Now we're reducing that skylight area to the perishable section. Now, I guess the overall savings for lighting is a bit reduced, specifically as we're going to more LED. The window of savings is not as large as it was with fluorescents, but by beefing up the envelope, by removing some skylights, we're able to make up for that lost lighting savings with more cooling savings. So before we move away from this slide, I do want to highlight this last item. Because the store locations are so dynamic, because we're implementing these initiatives, not a dozen initiatives on January 1, but as we work with Kroger to get them ready to hit the streets throughout the year or the years, the models become more important to really capture where we are in the present with each new store.
Great, thanks, Jeremy. This is Aaron Leo again. So now after having overviewed some of the processes and the projects that have informed our design and improved our design, we're going to go ahead and look at a few case studies, kind of looking at the evolution of the design and the impact that it actually has on our Energy Star design score and our actual Energy Star score. So first we're going to look at this Akeem Superstore 107. The open date for this store was beginning of January 2015, and we're calling this our initial prototype, not because this was the first prototype that KLH put together for us, but because this is what we're calling initial in a series of several new upgrades. So this initial prototype did not have the case controls, it didn't have the dedicated outside air system, and the LED upgrade to upgrading the sales floor lights to LED was completed several months after construction. So looking at kind of the two highlights here, the ENERGY STAR design score was 82. So a favorable score, a good score, and the actual ENERGY STAR score was a 95. So that brings up a few questions. One is, why is the actual ENERGY STAR score so much higher? One of the answers to that question is the LED upgrade, which was completed after construction, did heavily impact that ENERGY STAR score, as well as there are other items which improve the efficiency at the store, which would cause that score to bump up a little bit. So moving on to what we're calling our upgraded prototype, we're going to look at a couple of stores in this category. And this prototype includes the case controls on the refrigeration system, but does not include the dedicated outside air unit, and the LED upgrade was not completed with construction, similar to the previous store. In this case, we can see the ENERGY STAR design score, Design to Earn ENERGY STAR score, was an 89. So quite an improvement over the previous store. And the actual ENERGY STAR score was a 98, so a little bit of an increase there as well. So fortunately, what we're seeing is with the improved design, we're seeing an improved design score and an improved actual performance score. And we'll talk about this a little bit more, kind of summarized in a couple slides here. And just to kind of throw in another upgraded prototype store here, this store also in our Fry's market area includes case controls. Again, does not include the dedicated outside air systems or the LED upgrade with construction. And this had a design ENERGY STAR score of 91, so it's very, very similar to the last one, and an actual ENERGY STAR score of a 99. One thing we do know about this division is they're particularly vigilant in maintenance of their mechanical systems and their refrigeration systems, and that definitely reflects very positively on their actual performance score. And then finally, moving on to what we're calling our advanced prototype. So this prototype will include case controls, it will include the dedicated outside air system, and it will include LED lighting throughout the entire store, including the sales floor. So we have a store under this prototype that's slotted to be open in 2019, and this has a design score of a 99. So what we're seeing is a very good improvement in our design, and then obviously the actual ENERGY STAR score is yet to be determined. So looking at this as a whole, what we're seeing between the prototypes is a 21% increase in the ENERGY STAR design score. So basically, we're definitely on a great trajectory with where our design is heading. And as we talked about earlier in the presentation, obviously these scores are going to be affected by the new change with the new data coming into the portfolio manager on determining what your score is going to be. But we're heading in the right direction, and especially because of this change, these improved designs are going to help us to continue to meet ENERGY STAR certification. And then on the actual performance of these stores, I want to make a couple of notes. First of all, we do see a little bit of an increase, which is good. We're heading in the right direction. But a couple key features of this is as your ENERGY STAR score increases, it becomes more difficult to increase your ENERGY STAR score. And so the increase here in ENERGY STAR score is going to be reflected in a larger increase in energy efficiency, which is what we want to see. And the other piece is something I mentioned earlier. Our initial prototype had a few key upgrades early on, so its actual performance that we're seeing is higher than we would have originally expected it to be based on the design. But from the owner side, what we really want to see here is we really want to see, more than anything, that the actual performance is at or exceeding the design performance. Because what that gives us confidence in is that as we continue to improve design, our actual performance is going to exceed design. And that way we can depend on our design to meet our targets. So that's kind of the key that we want to pull out here, is that our design is increasing and our actual performance is exceeding that design.
To come back to tying the design team to the owner-operator, I wanted to share a brief synopsis of something that we've done that's kind of in a different light to our traditional consulting to Kroger, and that's looking at a couple of the LEED projects that we have worked with Kroger to produce. So twice, Kroger has decided to pursue, at a minimum, LEED certification for stores here local to the Cincinnati market. As we do with our other KLH projects, we either participate, or in this case, we hosted a LEED charrette with Kroger and the architect of record. And at that, we discussed, if we were to look at this project from the standard prototype view, what points could be achieved at the onset just using the standard prototype processes. We then took that a step further to look at what points could be achieved if we were just to make a few modifications to the prototype, be that accessories potentially to mechanical rooftop equipment or plumbing fixture changes, for example. And lastly, we identified those points that we saw as stretch goals. Again, coming back to our initial metric of making green decisions with good equipment ROI. We definitely kept that in mind as we set our design based upon the points that we wanted to achieve. We helped manage the submittal of all LEED points throughout the project, and we acted as a sounding board for the owner and the GC during the project construction. Now, this project in particular in Oakley, Ohio, was awarded LEED Silver. This store, as with the Palmer, Alaska store that I mentioned earlier, are project-specific examples where we've gotten into the weeds of making those green decisions to specifically impact the store's energy consumption, their energy models, and the Design Firm Energy Star scores. In the aggregate, most of the initiatives that are looked at are done as part of the bigger picture between Kroger and ourselves before the initiatives rolled out to the fleet, as Josh alluded to earlier. Lastly, I just wanted to touch on the remodel process and incorporating the initiatives into those remodels. Kroger's remodel projects will vary from a Tier 1 within the walls project to a Tier 4 remodel expansion scope. KLH usually attends a project scope walk with the project manager, and we will discuss with them what initiatives could apply to this project. Specifically, we want to look at two items. Is the initiative that we discuss, or the number of initiatives that we discuss, is it within the project budget? And number two, is it within the construction timeline? We wouldn't want to go into a store that is expected to open 3 or 4 months after the construction documents are complete and rip out a drop ceiling and put in skylights, for example. Finally, we work with Kroger's leadership here at General Office, the engineering team that Josh is a part of, and we'll really dive into the details of what including that initiative looks like and the value that it would bring to the store, again, the impact on the budget, et cetera. Going once again back to the metric of making green decisions with good equipment ROI.
So bringing this back to a few key lessons learned from this collaboration, something that we're seeing is that the industry is evolving quickly. There's a lot of new innovation out there, and the collaboration between Kroger and KLH allows us to move quicker. It allows us to take a number of different avenues to implement new designs into our new stores and our remodel. And secondly, what we're seeing is that these new prototypes are proving their value. We're seeing that their actual performance is exceeding design, and so we want to take that information and know that we can continue to use that in future design. So that's one way that these investigations are going to be informing our future design. And finally, and one of the most important takeaways I hope from this presentation is that training for installers and maintenance technicians of these new programs and processes and equipment is critical to success. You can have all of the best engineering on the planet going into these projects, but if the training is not there for those who are actually installing the project and for those who are maintaining the project, then there's no way that these are actually going to perform. So if you want to see the actual performance, this is critical to realize that from your design. With that, I'll go ahead and pass it back to Karen here to finish this up.
Thank you so much, Aaron and Michael and Jeremy and Mr. Horn. I didn't remember your first name, but I remember your last name. And that was a very insightful presentation, and I hope our attendees was able to gather and glean some good information from the session. And so the slide that I have up now is just kind of an overview of the activities that were just discussed and how KLH and Kroger work together, how they collaborate, and how they feed back into one another in order to create these performance activities. And this is really kind of going beyond the business as usual, having this type of dialogue. And we're going to open it up for questions. Zach is collecting the questions for us to collaborate on. But I wanted to ask Aaron and Jeremy real quickly before we put it out to the rest of the presenters, is this process of you all collaborating together, how long has this been going on? Is this new, or is this something that have started in recent years because of the information that you're being able to gather back and forth for one another? But I'll hope that's the question that I want to ask, but I'm going to continue through the rest of the slides. It's about 3 more slides, and then open it up, and then we can have a discussion. So the next one, here are references and acknowledgments for the article that I had in my presentation. And here are all of the resources from Energy Star, the tools and resources that you can use in order to implement some of these processes that Jeremy and Aaron and the Kroger team discussed. And secondly, we have our contact information slide. And I do believe you will receive a slide deck on your email if you left your email. And then lastly, we want to thank you all for being here and open it up for questions. And then we can do that and get started with the